Welcome to this video. So in this video, we are going to solve coordinate geometry questions. Okay. So these questions are coming from tutorial sheet 4. This is a tutorial sheet from University of Lusaka. Okay. But if you're from any other universities, you can still learn the concepts. Okay. So as I said, the tutorial sheet is on coordinate geometry. So you expect questions such as finding the equation of a line, okay, finding the midpoint, finding the area of different shapes, okay. Such questions, finding the center of the circle, the radius, how to sketch, okay, or draw the circle. Those are the questions that you expect in this tutorial sheet. So this tutorial sheet has about 3 questions, and I'm going to solve each and every question that you can see here. Okay, I'm going to solve each and every question that you can see here. So if you'd like to access the full video where I'll be solving all these questions, you are free to register with us. Just check in the description below. There's going to be a link, okay, that will show you a guide on how you can register for our lessons. And there's also a link to our website, okay, where you will do the actual registration. Okay, so we start with question 1 here. All right, so on question 1, they're saying the line L1 has the equation 2x plus 3y is equals to 6. And then the line L2 is parallel to line 1 and passes to the point 3, negative 5. Find an equation of line L2 in the form of y is equals to mx plus c. Okay, where m and c are constants. Okay, so from the information that we have been given here, they are saying line 1, okay, is parallel to what? Line 2. So what do what do they mean? Okay, when you have 2 lines that are parallel under coordinate geometry. Okay, so if you have 2 lines that are parallel under coordinate geometry, it means that their gradient is what? Is equal. Okay, so remember for line 1, we've been given this equation here, which is 2x plus 3y is equals to 6. Okay, so from this equation here, we can get the gradient of line 1. So what we need to do is represent this equation in standard form. So in standard form, it's just y is equals to mx and then plus what? Plus c. Okay, so that's the standard equation of a line. So it means here we have to make y the subject of a formula. So this is going to be 3y is equals to, we take this 2x to the other side, so it will be minus 2x, and then we have this plus 6. Okay, so we want only to make the y the subject. So we are going to divide throughout by this 3. So I'll divide here by 3, okay, there by 3, even there by 3. So it means my y will just be equals to, okay, y will just be equals to minus 2 over 3, and then x, and then plus, what is 6 divided by, what is 6 divided by 3? Okay, 6 divided by 3, we are going to get what? We're going to get 2. Okay, so it means this here is the equation of the what? This line 1 here. Right, so this m here in the line, the coefficient of x here represents the gradient. So we're going to say the gradient of line 1, we're going to call it m1, will just be equals to, so the coefficient of x here is what? Minus 2 over 3. Okay, so this is the gradient of what? Line 1. And then remember we said since these 2 lines are parallel, it means they're going to have the same what? Gradient. So it means even my m2, which is the gradient of line 2, will also be what? Minus 2 over 3. All right, so once we have the gradient for the line 2, it means it will be very easy for us to find the equation of the line. Remember, we've been told that line 2 is parallel to line 1 and passes through this point here. So for you to find the equation of a straight line, you only need a point and the gradient. So the gradient, we've found that m2 is just equals to what? Minus 2 over 3. And then the point is 3, minus 5, like that. So we're going to use these 2 to find the equation of the what? Of the straight line. So we're going to say the equation of a straight line is just y minus y1 is equals to, okay, in this case we can say y2 because we are dealing with line 2. So y2 and then is equals to m2 and then x minus x2. So this y2 and x2 come from this point here. Okay, so this one here will be our x2, then comma, this one will be our y2. So we're going to say y, and then minus, the y2 is minus 5 is equals to, our m2 is just minus 2 over 3, and then x, and then minus, what is our x2? Our x2 is 3, like that. Okay, so this is going to be y plus 5 is equals to, and then you multiply this with the x, you're going to get minus 2 over 3x, and then when you multiply this minus 2 over 3 with the minus 3 there, you're going to get plus 2. Okay, you're going to get plus 2 because this 3 and this 3 will cancel. Right, and then let's take this 5 to the other side so that we express it in the standard form here that they said. Okay, so what we are going to have there will just be y is equals to minus 2 over 3x, okay, plus 2. Then when I take this 5 to the other side to be minus 5, okay, so it means y will be equals to minus 2 over 3x, and then minus what? 3. So this here will be the equation of the line what? Of the line 2. Right, so that's how we answer this question A. We go to question B. Okay, so question B, they're saying the line A1 has the equation, okay, 10x minus 2y plus 7 is equals to 0. And then the first question here is find the gradient of line 1. Okay, so remember we said the standard equation of a straight line is just y is equals to mx plus c, where this m here is the gradient. Okay, so we want to express this equation here in form of this guy. So, okay, so let's leave the y alone. So we're going to have 10x plus 7 is equals to, we take this minus 2y to the other side, so it will be positive 2y. Okay, and then we can divide throughout by what? By 2. So I'll divide here by 2, here by 2, even there by 2. So what do I get there? Okay, we're going to get this. We're going to get y is equals to, okay, what is 10 divided by 2? That would be 5x, and then plus 7 over what? Over 2. So what is the gradient here? The gradient is just the coefficient of what? X. Okay, the gradient is just the coefficient of what? Of x. Okay, so we are going to say the gradient here, we can call it m1. Okay, it's just going to be equals to what? 5. Right, and then 2, they're saying the line L2 is parallel to the line 1. Okay, and passes to the point this. Okay, find an equation of L2. Okay, so we already have the gradient of the line 1, and then this line 2 is parallel to the line 1. So it means their gradients are equal. Okay, and then we also have this point. It means we can find the equation of the what? Of a straight line. So we are going to say the equation of a straight line is just y minus a. Okay, since we are finding line 2, I'm going to say y2 is equals to m2. Okay, and then x minus x2. So this x2 and y2, I'm going to get them from this coordinate. So this coordinate minus 1 over 3, comma, 4 over 3. Okay, this is my x2. This is my y2. If you want, they can be x1, y1. It won't change anything. Okay, and then this is my gradient here. Since the lines are parallel, it means even my m2 will be 5 still. So let's replace them now into this equation. So it will be y minus 4 over 3 is equals to 5, and then x minus, then minus 1 over what? 3. So this is what we have. So we are going to have y minus 4 over 3 is equals to 5, and then here to be x plus 1 over what? 3. Right, from here, let's expand what we have on the right. So we're going to have y minus 4 over 3 is equals to 5x, and then 5 multiplied by this, it will be 5 over what? Over 3. So this is what we have here, okay? And then from there, we can take this minus 4 over 3 to the right side to add it to this 5. So what we are going to have is y is equals to 5x plus 5 over 3. Then when this minus 4 over 3 comes to the other side, to be plus 4 over what? 3. Okay, so we can erase this part. What are we going to have there? Okay, so from there we are going to have this. Okay, we're going to say y is equals to, and then it will be 5x plus, so we add these two here. So they have a common denominator there, which is 3, and then it will just be 3 into 3, 1, and then 5 plus 4. So this would be 9 over 3, which will just be what? 3. So we're going to say plus 3. So this here will be the equation of the what? Of the line 2. Okay, so the line 2 will have this equation. So we're done with B2. We go to question C. Okay, so question C, they're saying the straight line L1 has the equation this, okay, and cuts the x-axis, okay, at the point A. Okay, so if the line cuts the x-axis at the point A, it means that at that point A, okay, at that point A, okay, let me write like this. So at that point A, it means the coordinate will be x comma 0 because it's on the x-axis. Okay, so on the x-axis, the y is always 0. So this is the form that the point A will have. Okay, so the first question they're saying find the gradient of L1. So we have 2y is equals to 3x plus 5. So we're just going to divide throughout by 2 like this. Okay, so what do we have? Y is equals to 3 over 2x plus 5 over what? Over 2. So this here is the equation in standard form. And then if you have the equation in standard form, it means you can get your what? Your coefficient of x, that will be your gradient. So the gradient of L1 will just be M1 is equals to this guy that I've put in the box here. So it will be 3 over what? 2. Right, so that's the gradient of L1. Okay, and then from there, the other question that they are asking there is that, okay, I think I should leave this equation here. Maybe we might use it. Okay, the other question that they are asking there is that, find the, okay, they're saying find the, or write down the x coordinate of point A. So remember I said point A is in this form, right? So how do we find the x coordinate here? We just substitute this 0 into this equation here. Okay, so where there's y here, we're going to put 0, and then we're going to solve for x. That's how we are going to find the x coordinate of the point what? A. Okay, so it will be, maybe we can just use the original equation. Yeah, so it will be like this. Okay, so the original equation is 2y is equals to 3x plus 5. So where there's y, we are putting this 0 now. So it will be 0 this side is equals to 3x plus 5. And then this will mean 3x is equals to minus 5, okay, which will mean x is equals to minus 5 over what? 3. Okay, so that will be the x coordinate. Okay, that will be the x coordinate of that point. Okay, so it means point A will just be minus 5 over 3 comma what? 0. All right, and then let's continue reading this question and solving it. So here now they're saying another straight line L2 intersects L1 at the point B with the x coordinate being what? 1. So we have another point B such that x is 1 and then y we do not know it, okay? And crosses the x-axis at the point C. So we have another point C. So if you cross something at the x-axis, it means the y is 0. So it's in this form. So here we'll need to find the x, there we'll need to find the y. Right, so here they're saying now, given that L2 is perpendicular to L1, okay? So whenever you hear that two lines are perpendicular, okay, then when you multiply their gradients, M1 multiplied by M2, the answer that you should get is minus 1. Okay, so we are going to use this equation to find the gradient of line 2. Okay, remember we said when they are parallel, the gradients are just equal, right? But when they are perpendicular, it means when you multiply the gradient of the first line with the gradient of the second line, what you should get is what? Minus 1. All right, so we are going to use this relationship here to find some things here. All right, so the question now here, they're saying find an equation of L2 in the form this, okay, where A, B, and C are integers. Okay, so how are we going to find that equation? Okay, so we first have to find the gradient of this line 2. We have to find this gradient, this M2. Okay, so the gradient of M1, we found it was what? 3 over 2. So we can say that the gradient of M2 is equals to minus 1 divided by what? M1. So this will be minus 1 divided by 3 over what? 2. Okay, 3 over 2. So it means that what we have here is minus 1 multiplied by 2 over what? 3. So what we're going to get here will just be minus 2 over what? 3. Okay, so this here will be our M2. So our M2 will just be minus 2 over what? 3. So once we find the gradient of line 2, okay, we can use a point to combine it with this gradient in order to find what? Its equation. Okay, so we were told that these two lines, okay, the line 1 and line 2 are intersecting at this point, what? B. Okay, so we're going to say since the two lines intersect at point B, we can substitute this x coordinate of the point B, okay, in line 1 to find the corresponding point of y. Okay, so what I mean is this. So let's erase this part. Okay, so we've been told that this line 2 and 1, okay, they intersect at this point B, right? And this point B has this coordinate. So it means we can get the x coordinate of this, okay? And then we input it into the equation of line 1 to find the coordinate of what? Y there. So what we're going to say is that line 1 is 2y is equals to 3x and then plus 5, okay? So this will be 2y is equals to 3. And then the x coordinate at this point is 1. Okay, and then plus what? 5. So this would be 2y is equals to, this would be 3 plus 5, which will just be 8. So we divide both sides by 2. So we're going to get y is equals to what? 4. So it means this point B here, okay, it's just 1 comma what? Comma 4. Okay, and then remember, line 1 and line 2 are intersecting at this point. So it means both of these lines pass through this point because they are intersecting. It's like this. Maybe this is line 1, okay? And then I have my line 2 here. So they are intersecting at this point B here, okay, which is 1 comma y. So it means both of them pass through this point, right? No wonder we use the equation of line 1 to find the value of y, okay? And then after we find the value of the value of y, I mean, we can use this point here, okay? And the gradient for the line 2 to find the equation of what? Line 2. So that's what we are going to do there, okay? So remember the general formula for finding the equation of a straight line. Okay, we say it's just y minus y. Since here I'll be finding line 2, I'm going to say y2 is equals to m2. Okay, and then x minus x2. So this would be y minus the x2 is 4. It's equals to the y m2 here is minus 2 over 3. And then I have x minus 1. Okay, so this would be y minus 4 is equals to okay, here we can multiply. So we can say okay, so here it's the same as minus 2x multiplied by 1 and then divided by what? 3. Since they said the equation should be in this form. Okay, so I'm now going to do a cross multiplication here. So 3 multiplied by this, it will be 3y minus 12 is equals to, then this minus 2 multiplied by this, it will be minus x and then plus what? 2. Okay, so from there we can put it in the form that they want. So the form that they want is that the x should start there. You can see ax. So I'll take this to the other side. So it will be 2x and then plus 3y. Okay, and then minus 12. Even this minus 2 follows. So it will be minus 2. I mean this positive 2. So when it goes to the other side, it's minus 2, right? And then this is equals to 0. Okay, so what we have here will be, okay, to be 2x plus 3y, okay, and then minus 14 is equals to 0. So we found the equation of line 2 in the format that they wanted. So this is line 2, okay, in the format that they wanted. All right. And then they're saying here, find the exact area of triangle ABC. Okay. So for us to find the area of triangle ABC, we need the coordinates of A, we need the coordinates of B, and we also need the coordinates of what? C. Okay. So the coordinates of A we have, the coordinates of B we have, but the coordinate of this C here, we do not have because it's still x comma 0. So we need to find this x. Okay. So now remember what they said in the question. Okay. They said another straight line, line 2, intersects line 1 at point B with x coordinate 1. Okay. And then this same line 2 crosses the x-axis at the point C. Okay. So if this line here, line 2, crosses at the x-axis at this point, okay, so it means we can put y as 0 and then we can find the x. So we're going to say 2x plus 3, this y is 0 minus 14 is equals to 0. So this will be 2x, okay, we can take the 14 to the other side, so it will just be equals to what? 4. I mean 14. So we are going to divide this by 2, divide this by 2. It means what we are going to have there is just x is equals to 2 into 14 to just be what? 7. Okay, so it means the x coordinate at this point C will just be 7. So it means C will just be 7 comma what? 0. Okay, so once we have the coordinates of all the 3 points, then we can go on now and find the what? The area. Okay, so let me erase these other things here, and then we have the space for finding the area. Okay. Right, so let me write the coordinates here. So A, okay, we have what coordinates? Okay, so on A we had minus 5 over 3 comma 0, and then B we have 1 comma 4, and then C we have 7 comma what? 0. So this is what we have. Okay, so these are the points that we have. All right, so how can we use these points to come up with the area of this triangle ABC? Okay, so let's have a rough sketch of what this triangle is going to look like. Okay, so if this is my x or y plane, I have my x there, then I have my y. Okay, so negative 5 over 3 comma 0, okay, should be somewhere here. So I'm just doing a rough sketch. So it should be somewhere there. And then this will be our point A. And then B, it is 1 comma 4. So 1 comma 4 can be somewhere there. So this will be our point B. And then 7 comma 0 will be somewhere there. Okay, so we can connect these lines. Okay, so our triangle is going to look something like this. So we want to find the area of this triangle. Okay, so there are two methods. One is the geometric method, okay, where you use a very simple formula to calculate the area. And then the other one is where you use the distance. Okay, so you can find the distance of BC, distance of AB, and then you use that formula for half is equals to BH for the right angled triangle, right? Okay, since they said L2 is perpendicular to L1, so should form a right angled triangle here. But if you don't want to use that, use the geometric method, which is very simple. So it's the one that I'm going to use here. Okay, so these coordinates on A here, we're going to say this is x1, this is y1. The coordinates on B, we're going to say this is x2, y2. The coordinates on C, we're going to say this is x3, and then y what? 3. Okay, so we're going to use those x1, x2 to find the area. Okay, so how do we find the area using the geometric method? It's very simple. We're going to say the area is equals to, okay, so I'm actually going to derive the formula that you should use. So you're going to say half, okay, then you're going to say modulus of, you write your x1 there, y1, okay, and then x2, y2, x3, and then y3, okay? And then at the end here, you write the one that you started with, which is what? X1, y1, okay, like that, okay? And then from here, we can come up with the formula for the area of the triangle under what? Coordinate geometry, okay? So what we are going to do here, we're going to say this is the same as half, okay? And then here I have the modulus of, so here now I'll be multiplying x1 multiplied by y2, y2 multiplied by, or x2 multiplied by y3, and then x3 multiplied by y1. So I'm going to have, okay, I'm going to have x1, y1, okay, and then plus, I'm going to have x2, y3. Okay, and then I'm going to say plus, and then here I'm going to say y3, I mean x3, okay, and then y1 like this, okay, and then after you are done multiplying in this direction like this, okay, you have to say minus, okay, and then now you start subtracting. Okay, so we start subtracting in this way. So I will use that, I'll use red there. So you multiply x1 with this, x3 with this, x2 with that. So what we have there is y1, I mean x1 and then y3. Okay, then we're saying plus, here we have x3 and then y2, and then plus, here we have x2, y1. Okay, and then we say close bracket like this, and then don't forget the modulus like this. So I think we can erase this other part. Okay, so that formula there that I've written is the one that we are going to use in order to come up with the what? With the area of this triangle. Okay, so I can move this part here so that it looks nice. So I can move this part. Okay, I can move it there. Okay, let me do that first. We can erase this part. Okay, we say this here comes like that. Okay, and then now we can get back this, put it there. Okay, I think this is better. So this is the formula that we are going to use, this one here. Okay, so our y1, x1, we get it from here. Our x2, y2, we get it from there. Even our what? x3, y3. All right, so let's put them in this formula. So we're going to say our area is equals to half, okay, modulus, and then here we're multiplying x1 multiplied by y2. So x1 is minus 5 over 3 multiplied by y2, which is 4, and then plus, we're multiplying x2, which is 1, multiplied by y3, which is 0, plus x3, which is 7, multiplied by y1 here, okay, which is what? y1 is 0, and then I'm saying minus. Then in the brackets here, I have x1, which is minus 5 over 3. I'm multiplying it by what? y3, which is 0, okay, plus, and then x3, okay, x3 is 7, multiplied by y2, y2 is 4, okay, and then plus, what is the x2? x2 is 1, okay, multiplied by, I have y1 there. So y1 is 0. So this is what I have, and then I say modulus. Okay, so this formula is very simple. So from here, we're going to say this is equals to 1 over 2. Okay, modulus. Here, when we multiply, we have minus 20 over 4. Here, we're going to get 0. Here, we're going to get 0. Okay, and then I'm going to say this minus. Here, I'm going to get 0. Okay, here, I'm going to get what? I'm going to get 28. Then there, I'm going to get 0. So we're just going to have this. So this will be equals to 1 over 2. Then modulus, okay, let's add this. So we can say over 1, and then over 4 there. Okay, this should be over 3. How did I write the 4 here? Okay, so because here we are multiplying 5 multiplied by 4 minus 20, and then we have that 3. Okay, so we can add this. So we can say common denominator there is what? 3. And then 3 into 3, it's 1 multiplied by minus that, be minus 20 minus, then 1 into 3, it's 3. 3 multiplied by 28, okay, 3 multiplied by 28, we're going to get 84. So this is what we have. So we are having half modulus of minus 20 plus, minus 20 minus 84, we're going to get minus 104 divided by 3. Okay, so this is what we have. And then from there, okay, we can erase this other part. Okay, from there, we can say we have that our area is equals to 1 over 2. Okay, what is the modulus of minus 104 over 3? Okay, we're just going to get there. 104 should be positive. Okay, we're going to get 104, then divided by 3. Okay, so this is what we get. Then here we can say 2 into 2, it is 1. 2 into 10, 4, or 104, we're going to get 52 over what? 3. Then we're going to say units squared. Okay, so this here is the area of the triangle ABC that is going to be what? To be formed. Okay, so we are done with question 1. Okay, if you've enjoyed this video, okay, you are welcome to register with us, okay, to access the other video where I'll be solving question 2 and question 3. All right, so thank you so much for watching this video. Have a blessed night.